Hello everyone. Today we are going to study more about the spherical mirrors, rules and their cases. For complete video, go to my YouTube channel and then subscribe. For more updates and notification, hit the bell icon. Let us study the rules for the spherical mirrors. Spherical mirrors are of two types, concave mirror and convex mirror. Yes. If I consider concave mirror, okay, the reflecting surface is always inwards. In case of convex mirror, the reflecting surface is outwards. You know, every reflecting surface is having a center and that center is called as pole. Yes. You know, if I consider this as a sphere, every sphere has a center and that center is called as center of curvature. Yes. Let me join these points. Yeah. You know, where the reflected rays meet, that is nothing but focus point. Let me extend this point. I mean to say, let me extend this line. If I extend this line, that is nothing but principal axis. If you consider convex mirror, this is going to be your pole, yes, and this is going to be your center of curvature. This is going to be your focus point. If I extend this line, this is going to be your principal axis. As I already told you, convex mirror, the reflecting surface for convex mirror will be outwards. Now, let us see the rules. The first rule says that when an incident ray is parallel to the principal axis, then the reflected ray passes through the focus. So let me draw an incident ray which is parallel to the principal axis. Yes. Then remember that reflected ray passes through the focus. This is going to be your first rule. Next, let us study the next rule. Yeah. Center of curvature, focus point and then principal axis. If an incident ray passes through the focus point, if an incident ray passes through the focus point, then the reflected ray is parallel to the principal axis. This is going to be your second rule. Let us study the third rule. This is going to be your pole, this is going to be your center of curvature, focus and then principal axis. If an incident ray passes through the center of curvature, if I consider this as an incident ray and it passes through the center of the curvature, then the reflected ray comes back in the same direction. So this is your third rule. Similarly, let us move on to the convex mirror. You know, convex mirrors are always diverging. Yes. Let me consider the first rule. If an incident ray is parallel to the principal axis, then the reflected ray appears to pass through the focus. Okay. So it is going to pass through the focus. That means appears to pass through the focus. So here it is passing. Clear? So this is your incident ray and this is going to be your reflected ray. Similarly, let us see the second rule. Pole, center of curvature, focus and then principal axis. Second rule, what we have seen, if an incident ray passes through the focus, here you have to use appears to pass through the focus. Okay, if an incident ray appears to pass through the focus, then the reflected ray is parallel to the principal axis. Yes. Let us see the third rule. This is going to be your pole, center of curvature and then focus, and this is going to be your principal axis. If an incident ray passes through the center of curvature, if an incident ray appears to pass through the center of the curvature, okay, appears, use the word appears in case of convex mirror, appears to pass through the center of the curvature, then the reflected ray also comes back in the same direction. Okay, these were the rules for the spherical mirrors. Remember guys,